Everybody, I want to show you how to solve radical equations. So those are equations that have radicals in them. And yeah, let me just get going. So these range from quite easy, like this one, to pretty messy, and they change pretty fast. And I'll show you the criteria for when they're easy versus when they're hard. So the basic idea here is that you use powers to cancel out the radicals. That's essentially what we're doing. So I've got a square root. I can cancel out a square root with a squared. So since I have the square root of something on the left side, I'm just going to, and nothing else over there, I'm just going to square both sides of this equation. Right, that's a thing I can do because I'm doing the same thing to both sides of the equation. Now, I want to emphasize that I'm squaring the side, not each of the things on the side. I know that's what it looks like here, but that's going to matter a lot when we go to the next thing. So yeah, the square this square root, and we just get them canceling. That's the idea. So we get x minus 5 equals 16, so x equals 21. That was easy. You can check this by putting it back in, right? 21 minus 5 is 16. Square root of that is 4. Good to go. Okay, that one's easy. How about this one? That doesn't look that much different. This one's much harder. So here's why it's hard. So I want to get down to the situation I was in last time, where I just have a square root on one side and the other stuff on the other side. And so I'm going to add 3 to both sides. So I have square root of 3m plus 1 equals m minus 1. And remember when I said I was squaring the side, not each of the things on the side? Well, when I square the left side, it works fine. When I square the right side, I have to multiply that out. That's a polynomial that I have to FOIL out. So the left side, easy enough, 3m plus 1. The right side, I have to multiply out m minus 1 times m minus 1. And this happens every time you have more than one term on the side that you are squaring. There's no way to get out of this. There's not like a shortcut around it or anything like that. You just have to do it. Squared minus 2m plus 1. And so now we have to solve this equation. So, well, it's a quadratic equation because I have a squared in it. So that means I need to get everything on one side and set it equal to 0. I'm going to move everything to the right to keep the m squared positive. Certainly, you could put everything on the left if you want to, and then factor or change the sign or whatever. So minus 3m minus 1 gives me 0 equals, oops. No, I did that right. What's going on here? I know this works out. Well, anyway, m squared, oh, there we go, minus 5m. There we go, plus 1 minus 1 is 0. Sorry, I thought it was minus 2 and thought I was messing this up. M squared minus 5m. So the way to factor this is it's got a greatest common factor of m, so I'm going to go ahead and pull that out. We have m times m minus 5 equals 0. And that leaves me m equals 0 or m equals 5. Now, here's the thing that can happen. It is very easy to get extraneous solutions when you are dealing with radicals, because sometimes some of these will not work out in the initial equation. Like, for instance, if I had a negative number for m, which is entirely a thing that I could get, I didn't this time, but that is a possibility. If I had something that didn't work out for m, or something that made the number under the radical negative, I would have to throw that answer out. Let's see if that happens here. So if I get m equals 0, I put that back in, and that gives me, let's start writing this. So m equals 0 gives me square root of 1 minus 3 equals 0 minus 4. Is that true? 1 minus 3 is negative 2. So no, it's not true. So that didn't work, right? And so this happens all the time with radicals, actually probably more often than with rational exponents. So m equals 0 doesn't work out, and the only answer I have is m equals 5, which I suppose we should check it. I know it works, but let's go look at it anyway. So the square root of, if n is 5, we get 16, so we get square root of 16 minus 3 equals 5 minus 4. Yeah, that's true, right? So 1 on the left, 1 on the right. So yeah, 5 works, 0 does not. And this is super, super common among radicals. So make sure you check your answers. It's very often that you'll do everything right. Like I didn't make any mistakes here. But when you square both sides, so basically the upshot is this. When you square both sides of an equation, you're kind of destroying the negative answers because the squaring gets rid of the negatives. So you can be either destroying answers that work or sometimes adding answers that don't. So you got to check the answers that you get. All right, let me move on to the next one. All right, this is where it's going to start to get messy. So I want to have the same strategy as before. I want to get a radical on one side and everything else on the other, and then square both sides. So I'm gonna do that. I'm gonna move the y minus 4 over by adding square root of y minus 4 to both sides. And so on the left side, I'm gonna have the square root of y plus 1. And on the right side, I'm gonna have 1 plus the square root of y minus 4. And then I'm gonna square both sides so that I get rid of the radical on the left. However, on the right, things are going to get a little bit messy. So on the left, that's easy, 5 plus 1. On the right, I'm going to need to get a piece of scratch screen here. So I'm going to get 1 plus the square root of y minus 4 quantity squared. So that's the same thing as having this, which is two binomials. Well, not exactly binomials since they're not polynomials, but two things with two terms in them. So I have to FOIL, right? Here, 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 here. So 1 times 1 is 1. 1 times square root of y minus 4 is square root of y minus 4, plus another copy of the square root of y minus 4, plus square root of y minus 4 squared. So this and this are the same thing, so it's really just two of them. So this is 1 plus 2 root y minus 4 plus, well, this thing, the squared and the square root cancel. I just get that. So the thing I have here is, what's this? Y plus 2 root y minus 4 minus 3. Right, so not the nicest looking thing, but that is what we've got. So so that's the thing that's gonna go on the right side. That one. Y plus 2 root y minus 4. Was it plus 3 or minus 3? It's gotta be minus 3, right? Sorry, getting forgetful. Yeah, minus 3. Okay. This looks terrible, but actually is not that bad. And the reason it's not that bad is that I've got, I went down from 2 radicals down to 1 radical, and all that's left here is a bunch of like y's and numbers. And so I can get all those on one side. So all of those that I've got, I'm going to collect all the terms that aren't the radical over on the left side. So I'm going to go minus y plus 3 minus y plus 3. And that's going to give me over here, the y's cancel, which is nice. And I get 4 equals over here, those cancel 2 root y minus 4. All right, that's not bad at all, actually. This is a relatively simple thing to finish off. So I have a 2 root y minus 4 equals 4. I'm going to divide both sides by 2. You actually don't have to do that before you square, but I think it makes it simpler. Right, this is back to basically the first one we had. So I'm going to square both sides, y minus 4 equals 4, add 4 to both sides, and y equals 8. Now, as always, there was a point, in fact, 2 of them, where we squared both sides, so we absolutely need to check this and make sure it works out. So if I do that, square root of 9 is 3, square root of 4 is 2, 3 minus 2 does in fact equal 1. So there we go. Great. So that's the thing to watch. That's a thing to watch out for here. This actually worked out a little bit nicer than some of these do. It can be the case that you get down to here and there's still some y's left over here, right? They don't have to cancel out like this. These did, which made it a little bit nicer, but there could still be like a y left over here. And then when you square both sides, you get, you have to square another binomial, and so you end up having to factor it at the end. So it can, or not necessarily factor it, you could use quadratic formula, but this one actually worked out a little bit friendlier than they sometimes do. However, not so bad, right? Yeah, not so bad in this case. Just watch out for when the y's don't cancel off and you get something more like the previous one, like this, right? Where you get something like this and have to factor it or use the quadratic formula at the end. All right, this one, I bet you look at that and go, that looks horrendous, right? We're going to be cubing things this time. This one's actually really, really easy. The reason it's really easy is that this number is a 0. If this is anything other than 0, this gets really bad, like really, really bad. I promise I will not give you one that bad. But since it's a 0, when I add this term over here, which is what I'm going to do, I'm going to add this term over to the other side. It all works out nicely. The cube roots just go away, and then you're done. So I'm going to add the third root of y minus 11 to both sides. It looks like I'm dividing that. Let me get rid of that. I don't want to give the wrong impression in the video here. Y minus 11. So here they cancel. Here I'm left with the third root of y minus 11. So I have the third root of 2y plus 6, which I realize now I should definitely have written over. Whoa, that is not what I meant to do at all. Holy moly. I didn't even know that was an option in Zoom. One more try. That's where I should have written that just for clarity. Sorry. Didn't mean to have that random aside, and that equals the third root of y minus 11, which I kind of want to write a little closer to each other, just so you can see that the step that we're going to take here is the obvious one, which is we're going to raise both sides to the third power. And because there was a 0 on the right side, everything works out great. Right? Nothing to it. Subtract 6 and subtract y, or just subtract the y to the left. Get 3y plus 6 equals negative 11. Subtract 6, 3y equals negative 17. And y is negative 17 over 3. Great. So one thing I should point out, because this is a third root, as far as I know, it's impossible to add extraneous solutions by cubing both sides. It only happens with even powers. So you don't even really need to look for extraneous solutions if we've got an odd root. So there we go. Negative 17 over 3 is my answer. I believe that was the last thing I wanted to say. Is that true? Yep. And that's it. That's all I have for you. So the basic idea is this. We want to use powers to cancel out radicals. Third powers cancel out third roots. Second powers cancel out square roots. In general, the basic strategy is to get a radical on one side and all the other junk on the other side. Sometimes that is kind of a problem when the other junk has radicals in it. Like, this one's not so bad, but like when the other junk that we're getting on the right side, that's not the radical, has more than one term, you got to FOIL it out. So if there's variables, sometimes it gets a little messy. And if there's radicals, sometimes it can get really messy. This one's not really messy. It's a little bit messy. Like when I didn't write the squared. When I squared both sides here, I actually needed a piece of scratch screen to do this, right? So you just want to treat this thing here like one piece, or like that's your variable that you're foiling. And remember that when you multiply it by itself, that's squaring it, and that just gets rid of the square root. So once you do that, then you'll end up with a radical left from the middle term. So you got to do it again, right? And so sometimes that's relatively neat, like it is here. Sometimes that can be kind of a mess, like when there's variables over here, and then you're back into this situation here where you have to factor. Always check your answers at the end when you have to raise something to any even power. I won't give you anything hard to raise a power to, or raise to a power aside from just a squared. Anything I give you with like a third root where you would have to do a third power, I promise I will not give you something where you have multiple terms that you have to raise to a third power. That gets bad. That's harder than I want to do in this class. It is a thing you can do. It is not a fun thing to do, and we're not going to do it. So when there's a 0 over here, that's when your life is easy, because that just means that when you raise to the third power, there's no foiling, there's no multiplying binomials, nothing like that. It just cancels. Great. Okay, I think that's the last thing I want to say. So I will go ahead and stop talking now, and I'll see you guys in the next video, which will be the last one.